Recording in progress.
Good morning. Guys, we're going to cover the last three problems that we didn't get to in class and I asked you guys to work on for homework. So for those of you that were here on Monday, go ahead and watch through this so you can check your answers or find out where you got hung up trying to work on it. For anybody that was not here on Monday, once I finish 29, 32, and 35, I'm going to go back to 5 and work through the rest of those, which is pretty much what we did on Monday. Okay, so starting off, so 29, we have the problem 8 times x minus 9 squared plus 11 equals negative 10. All right, so for this one, again, you want to isolate your squared term. So we end up with the squared term on the left, everything else on the right, and then we use the square root property to solve for a variable. Okay, so we're gonna get rid of the 11 first. Brain always gets ahead of itself. Try to write the answer. 8 times x minus 9 squared equals negative 21. And then the only other thing we have to get rid of is the 8, because our square term is the x minus 9. So we divide both sides by 8. Unfortunately, this one's a little uglier than the ones we've done previously because not only do we have a negative term, but we have a fraction. Leave it in fraction form. Don't turn it into a decimal. All right, so now we're going to square both of these. So actually, let me go ahead and just write it over here. So the next step, after you've turned it into the quadratic equation, is we use the square root property. So square root of x minus 9 squared equals the square root of negative 21 over 8. All right, so obviously on this side, that's our goal, is we're isolating the square term. Square root cancels out squared, they're inverse operations. So we're left with x minus 9 on the left. And then on the other side, I'm going to go ahead and sort of split my radical. So I have the square root of negative 21 over the square root of 8. So this is the side we want to simplify. First, we need to simplify. You could sort of pick and choose whichever you want. You could either take out your negative 1, because remember, the whole reason we're doing this is because we learned that I is equal to the square root of negative 1, since you can't have a negative inside of a square root. That's our imaginary number, so we represent it with I. The other thing that we have to do is we have to get that 8 out of the denominator, or the square root of 8. You can't have a square root in a denominator. So you could do either one first. I'm going to go ahead and fix my denominator first. So I'm going to multiply both the numerator and the denominator by the square root of 8. That way I can get rid of the square root in the denominator, but I'm not changing the value of the fraction. I'm just multiplying times 1. All right, and so this gives me the square root of negative 21 times 8 over negative, or square root of 8 times square root of 8 is 8, right? So by doing this, we've created the square root of 8 squared, and those cancel each other out, and we're left with 8. So now we've gotten rid of the radical in the denominator. Now I need to clean up my numerator. So cleaning up my numerator, I want to take out the negative first. So I'm always not sure how to do this with you guys, whether it's confusing. So mostly you just know that if you take out a negative, you add an I. So that's sort of the shortcut. If you've got a negative inside your radical, just take the negative away, put an I on the outside, and you're done. You can sort of do like this kind of number. But I still want to simplify inside because I've got some perfect squares inside this radical. So to clean that up, I'm going to go over here. I've got 21. I know that 8 is 4 times 2. So technically I've got like a 2 cubed. But 2 squared is, can pull a 2 out of a radical. Like the 2 squared cancels out the square root. So I'm going to write it like this for you guys right now. But just know for every even number you have in an exponent, you can pull that many of the root number out, which in this case is 2. So this sort of gets canceled because of square root, and it can move outside of my square root, my radical. So I have a plus or minus 2, and then inside, 21 is just 3 times 7. there's no perfect squares in there. So it's 3 times 7 times 2, which is 42. So I have the numerator becomes plus or minus 2 square root of 42. So let's bring that back down here, kind of all of this that I've done. And I end up with x minus 9 equals plus or minus 2 square root of 42 divided by 8. And then I've got an I in there. All right. Now I can reduce this 2 goes into the 8 4 times. So I can reduce that again to plus or minus the square root of 42 over 4i. Okay. Now I still have this negative 9 over with x. So let me just rewrite it. I know I'm so all over the place right now. Plus or minus square root of 42 over 4i. And then I need to add a 9 to both sides. I'm just going to put it on the end here because that's just weird. But we're going to definitely change the order. Okay, so x equals 9 plus or minus the square root of 42 over 4i. And that is our answer. Definitely complicated, but if you understand the process, you've just got a lot of little pieces that you're doing, simplifying the different parts of the radicals, but it all comes together. It's fairly simple math once you can understand how to simplify square roots. Okay, the next one was 32. So for 32, I get my pen to work. Let's see. Okay, so using the formula h equals negative 16t squared plus, this is vi, the initial velocity times time, plus the initial height. Determine the time it takes for an object to fall from each height. The height that they gave us is, for 32, is 9,200 feet. All right. Assume no initial no initial vertical velocity and negligible air resistance. Use a calculator and round answers to the nearest tenth of a second. Okay, calculator. So first we need to take the values that we know, plug them into our formula, and then we are being asked to solve for time. So t is that's our x. That's our variable that we're solving for. All right, so the height plugs into the h 9,200 feet. That is the, hold on, let me take I'm gonna take my units out. That's the height that the item is falling. Okay, and then we have negative 16t squared. And then they said, assume no initial vertical velocity. So that means that our the initial vertical velocity was 0. So that's just a 0t, which cancels it out. And, oh, hold on. Let's see here. And round answers to the nearest 10th. And then our, my bad, hold on just a second. Height, the height is 0. Sorry, it's falling down. So the end result is the ground, which is a height of 0. That 9,200 feet is our initial height. Yeah. So plus 9,200 feet. There we go. Okay. Determine time it takes for object to fall from each height. Yeah, so its initial height is starting at 9,200 feet. It ends at ground 0. So that's where your 0 goes. Okay, so I am going to move my negative, because I want my t squared term to be on the left. So I'm going to move this guy, t squared, over here. I end up with 16t squared. Now everything's nice and positive. over 9,200. But I also need to divide by 16. So, because the t is my only squared term, the 16 is not being squared. Okay, I feel like 16 goes into 92. But probably not quite. So it goes into a 5, I think 5 times. Hold on, let me do the math. Okay, it goes into 9,200, 575 times. All right, so now we need to square both sides. So at this point, we've got our sort of initial quadratic equation. We need to use the square root property now. Square root of t squared equals the square root of 575. And so t equals, let's do square root, oh, that's weird, 575 square root equals approximately plus or minus 23.98. So I'm going to round that to, they wanted to what? The nearest tenth of a second. So that rounds to this place, which means 24.0 seconds. And that's our answer. So it takes this object 24 seconds to fall 9,200 feet. Okay, last one. Now, the last one you're really gonna kind of need to have your books for because you've got a baseball field diagram. So they want us to write a quadratic equation and then solve it. They want us to find the distance from home plate to second base on an official Little League baseball field. Okay, so 35. Let's start with my abysmal art. There's 1, 2, something like this. They've got us a baseball field. It's a little sideways. But they're telling us that each distance here is, I guess it's a square, so it's an understood 60 feet on the other side. That if we have our pitcher's mound here, this gives us 46 feet. From the pitcher's mound to the midpoint, which that's not even close, but this is me we're talking about. This is 50 feet. All right, so find the distance from home plate to second base on an official Little League baseball field. All right, so we want this right, well, not obviously not from way out there, but let me make it a different color. We want this distance right here. Okay, so if you'll notice, in their case, this is a perfect square. Mine's a little more of like a parallelogram, but there are assumed right angles at each plate. So you have a you have a right triangle. So let's say this right here is second base, this is first base, and this is home. I've just turned it sideways a little bit. And we have, close. Can't help myself. And we are finding home plate second base. Well, then understood that that's a right triangle. That this from home plate to first base is 60 feet. First base, second base is 60 feet. And so you see that we have, so this is C. We want to find the hypotenuse. So we have, we can use our quadratic equation. So we have a squared plus b squared equals c squared. C squared is what we're trying to find. So I'm going to write that the other way. So c squared equals 60 feet squared plus 60 feet squared. And so that's, let's see, so 36 and then 2 zeros plus 36 and 2 zeros. Number 2. And so we have 0, 0, 6 plus 6 is 12, 0, 1, 6, 7, 7,200 is c squared. Okay. So now we use our square root property. So the square root of c squared equals the square root of 7,200. And again, I'm just going to go ahead and use my calculator real quick. Here, the square root of 7,200 is approximately 84.85. So I'm going to round that to 84.9 feet. So it is approximately 84.9 feet from home to second base. And that's it. Okay, so that covers the problems that I asked you guys to do for homework. Hopefully y'all were able to figure those out. Let me go ahead and work on the others for anybody who was not here on Monday. Number 5, let me just move this so I don't forget what I'm working on. Oops, suppose my number 5. So number 5, we had, so now we're practicing with those imaginary numbers. So we have the square root of -4. This just breaks down, you can always break down everything into the square root of the factors, because as long as you're multiplying or dividing, you can sort of apply that square root to every individual factor. Just keep in mind that there's multiplication between the two. So this is the same thing as -1 times the square root of 4. We know the square root of -1 is I, and the square root of 4 is a perfect square. So that's 2 squared, squared minus, or squared cancels out square root. So you end up with 2i, and that is your answer. We write that with, just like any other term, we write the coefficient in front of the variable, treat the I like a variable, and write it as 2i. Also, because this isn't an equation, we're just simplifying. You don't include the plus or minus. All right, so number 11, we have, oh, okay, so here we go. This one's kind of similar to maybe number 32 that we did with the fraction. So we have the square root of -48/5. So again, because we're dividing, and this isn't an even division, we don't get a whole number, then I'm going to apply that square root to the numerator, and I'm going to bring my negative up there, and I'm going to apply it to my denominator. So again, we run into a similar thing. You can either go ahead and take out your negative now and put an I on the outside, or you can get rid of your denominator. I like to clean up the denominators first. It doesn't really matter. But I'm going to multiply it times 1 in the form square root of 5 over square root of 5. That gets rid of the square root in my denominator, and that just becomes a 5. And then my numerator, I'm going to keep that 5 separate because I know 5 is a prime number, and there's not going to be a 5 in 48. So I'm not going to be able to pull out any perfect squares there. So I'm just going to leave it 48 times 5. All right, I'm also going to look at at this point, you could take out make that a positive and bring out your I. I want to look at the prime factorization of 48. So 48, I feel like we figured this out, but I know it's 4 times 12, and 4 is a perfect square. But 12 is also 4 times 3. So I have another perfect square. So essentially, I can go ahead and write that 45. I'm going to do it this way. I'm kind of do it different ways. This is 4 squared. So I've got 2 of them. 4 times 4 times 3. So 4 times 4 times 3 times 5 over 5. Keep that I on the outside so I don't forget about it. So now I know that I can bring that 4 out of my square root because I can cancel like the square root and the square just for that factor. So I'm going to bring out the 4, And I'm left inside the square root with the 3 times 5. So I'm going to simplify that to 15. Put my 5 in the denominator, my I on the outside, and I'm done. So 4 times square root of 15 over 5I is our answer. Again, if this had been an equation, x equals the square root of negative 48 over 5, we would have a plus or minus in front of it because we don't know if x is positive or negative. But we're just simplifying, so we don't have to do that now. Okay, number 14. Number 14 should be moving, yeah, it moves into our solve by taking roots. So we have sort of our basic quadratic equation here, y squared equals negative 36. So we take the square root of both of these. Y squared equals the square root of negative 36. These cancel out and we're left with the root number, which is a root variable, which is y. I'm going to separate this one into the square root of negative 1 times the square root of 36. Square root of negative 1 equals I. So there's that gets rid of our negative. And 36 is a perfect square. This is 6 times 6. So our final answer is y equals plus or minus 6i. Now we have to have that plus or minus in front of it because it's representing a variable. And that variable could be the positive version or the negative. Okay, 18. So for 18, we have b squared plus 45. This one's sort of the next step. We have to turn it into quadratic equation form where we have our square term on the left and then our the rest, everything else on the right, in this case, constant. So I've got to move that 45 over. And I get b squared equals negative 45. Now I can use my square root property. B squared, square root of b squared equals the square root of negative 45. These cancel out and I'm left with my variable b. And for this one, we know there's a negative 1 in there, so I'm going to take that out. We know that the 45 is 9 times 5. And 9 is 3 squared, so it's a perfect square. So this becomes an I, and this becomes 3 square root of 5. Is that 9 is 3 squared? So I can pull out a 3. And so when I combine this is a little bit different. So I have my plus or minus. I'm going to put the I with the 3, and then the square root of 5 after it. It's just kind of a form thing. Rewrite it. So keep the I with the constant, unless it's a fraction. If you have a fraction like we did in number 11, you just keep the I on the outside of the fraction. All right, 18, 23, and 26, and then we're done. All right, for number 23, we have 7x squared minus 22 equals 4x squared plus 8. It looks complicated. It really is not. And in this case, it's actually a very simple problem. It's just teaching you to don't forget the basics of just combining like terms until you get an answer where you have everything being squared on the left side and everything else on the right. So I have to move my 4x squared term over. Just for now, because we're adding and subtracting, we move the whole thing. I'm also going to go ahead and move my 22 over to the right. So these cancel, and I'm left with 3x squared equals 30. Now, the 3 is not being squared, only the x. So I've got to get rid of the 3, and I have x squared equals 10. This one, again, really, really simple. So x squared equals 10. We square both sides. There is no perfect square that exists in the factors of 10. So you just cancel these guys out, and x equals plus or minus square root of 10. That's it. Don't even worry about like solving it using calculator to solve to approximation. Okay, 26 is 2 times r plus 6 squared equals 18. I feel like for a lot of you, your first initial reaction is to distribute the 2 into the parentheses. Unfortunately, the parentheses are there because the r plus 6 is being squared. The 2 is not being squared. So you cannot distribute it into the parentheses because the r plus 6 is being squared and the 2, that wouldn't work. We can't do that. So in this case, what you're going to do is the only thing not being squared on the left side is the 2. So we need to move that over here to cancel those out. So we leave our squared expression in this case together. And 2 goes in 9 times, which this will be nice. At least now we've got a perfect square in there. So square root of r plus 6 squared equals square root of 9. So I can simplify this into r plus 6. I can simplify, so this is just, my specialty is everything. This is 3 squared. So I cancel those out. Hold on, but it's a plus or minus. So these are not quite the same. So we have, well, but what we can do is because now we have no square root, we have no I, we can actually solve them. I know, square root, developing a speech impediment. So we have r equals 6 plus or minus 3. So this means r equals, wait a minute, that's negative, negative 6 plus 3, which is negative 3. And r equals negative 6 minus 3, which is negative 9. And those are our 2 answers. So we have 2 actual solutions here that don't have a square root or a weird imaginary number. All right, that's it for what we did in class yesterday. It was a delayed day, so we only had about 30 minutes. So this covers kind of everything. If you guys watch this, you should be caught up. And then we're going to start section 5.5 tomorrow. All right, thanks so much. Bye.